Alright guys, now we're going to be looking at analytic trigonometry. So, fundamental identities. You are going to be using these all chapter. Evaluate the sine expression. Okay? Inverse sine of 4/5. Now, remember, you should be in radians. Okay? That's what I would do. So, this would be 0.93. This equals 2.75. Factor the expression into a product of linear factors. Okay, so what multiplies to -4 and adds -3? So that's going to be 2a minus 2a plus b, a minus b, or a minus 2b. What multiplies 9 adds to 6, that's 3u minus 1, 3u minus 1. Factoring, we need to remember how to factor, guys. That's going to be a big part. So this one you got to multiply by x over x, y over y. So I get 2x minus 3y divided by xy. Quick review. There we go. So they did both. Okay. What you learn about identities, basic trig identities, Pythagorean identities, cofunction identities, odd-even identities, simplifying trig expressions, solving trigonometric equations. Okay? And why identities are important when working with trigonometric functions in calculus. Reciprocal identities. We know these. Quotient identities. We know those. These we know. Pythagorean ones. A squared plus b squared equals c squared. Well, cosine squared plus sine squared equals 1. 1 plus tangent squared equals secant squared. These are key. You are going to need to be able to use these. You need to write these down. You need to know these. So find sine and cosine if tangent is 3 and cosine is less than 0. Okay. So what's the only thing, didn't we just learn 1 plus tangent squared equals secant squared? So we can say 1 plus 3 squared equals secant squared. So I get 10 equals secant squared theta. Take the square root. So I get positive or negative. I'm going to change this to 1 over cosine. Okay. So hold on. So then the cosine is the -1 over the square root of 10 because it said cosine is less than 0. And now we can find sine squared because we know sine squared plus cosine squared equals 1. Or, so I think we also could have done this. So the tangent was 3, so opposite over adjacent. So that makes this square root of 10. So yeah, so the sine of theta let's see, tangent was positive, cosine was negative, so that means sine has to also be negative. So it would be -3 over the square root of 10. Let's see. There we go. So we actually didn't need that identity. We could have set up the triangle like we learned last time. Okay? Cofunction identities. We know all these. How to find the sine and cosine of each angle. Okay, so here's the thing. If you do pi minus 2 minus theta, that's the same thing as cosine of theta. Or if you do pi minus 2 minus theta, cosine pi minus 2, it's the same thing as sine. So these are things we also need to be able to use. Okay? Even and odd. So we know every trig function is either even or odd. So sine of negative x equals negative sine x, and cosine negative x equals cosine x. Tangent negative x equals negative tangent of x. Same thing with cotangent. So see how the sines and cosecants, cosine, secant, they still match, okay? So here's the things we used. Alright, simplify the expression cosine to the third plus cosine x sine x. Well, what do they have in common? Cosine. So if I factor out a cosine, I get cosine squared x plus sine squared x. What does that equal? 1. So I get cosine x times 1, so I get that is the cosine of x. So there we go. Alright. So let's see here. We're going to have to use some of these. I'd multiply the top out. I'd get cosecant squared x minus 1 over cosine squared x. Okay. But let's see, if we subtract 1 over here, this is equal to cotangent squared x over cosine squared x. And cotangent is cosine squared over sine squared divided by cosine squared. So if I multiply by 1 over cosine squared, I get 1 over sine squared, which is equal to secant squared x. Not secant. I always do that. That's a bad mistake for me. Cosecant squared x. Let's see if we're right. There we go. Find all the values of x in the interval from 0 to 2 pi that solve that equation. So let's see if we can simplify anything here. I get sine to the third x equals sine x over cosine x, because that's what tangent is. So if I multiply both sides by cosine x, those cancel out. I'm going to subtract the sine x over. Let's see, factor out a sine. And hold on, that doesn't equal x, that equals 0. Well, and then wouldn't that be sine x, and that is cosine squared x because of this? So then I get sine of x equals 0. Where does sine x equal 0? Between 0 and 2 pi? Not equal to 2 pi, so 0. So I get x equals 0. And then cosine squared x equals 0, so square root both sides, you get cosine. Where does cosine equal 0 between 0 and 2 pi? Pi over 2 and 3 pi over 2. Let's see if we're right. Oh, yep. So I missed a couple things. So I wasn't using my head here. We can't do cosine squared because if you go back to the original, which is what I always forget to do, is check my answers. That would make it undefined. And then I also forgot that it's actually x equals 0 and pi. Okay? So we have to learn from our mistakes, guys. That's what I'm trying to show. Learn from the mistakes. So we can't forget to check. But we have to be able to use these properties. Let's be ready to roll.